Hi guys, so let's discuss the topics of the redox. Redox is a combination of the two words, reduction and oxidation. Oxidation is a process of the losing of the electrons. Usually metals act as a reducing agent that will donate the electrons. Here you can see example when calcium donates 2 electrons with the formation of the calcium ion. Addition of the oxygen, it's a type of the oxidation process. So any combustion processes, or for example when iron react with the oxygen with the formation of the iron oxide, so rust. Process of the losing of the hydrogen also considered as the oxidation reaction. For example, we can provide example when hydrochloric acid will react with the oxygen with the formation of the chlorine gas and the water. So what about the reduction process? Reduction process vice versa. So it's a process of the gaining of the electrons. And usually nonmetals act as the acceptors of the electrons or oxidizing agents. So here you'll find example when chlorine will accept 2 electrons with the formation of the chlorine ion. So if addition of oxygen it's oxidation process, losing of the oxygen it's a reduction process. Here you'll find example when more active carbon will replace copper from the copper oxide with the formation of the carbon dioxide. And addition of the hydrogen, I hope logic already clear, it's a reduction process. So here example with the ethene and the hydrogen which will form a ethane molecule. Oxidation state. Oxidation state is a charge that an atom will have if all bonds were completely ionic. So here it's very important to be able to find difference between the charge and oxidation state. Charge you will write above the symbol, and first you will write the number and after the sign. Oxidation state, first you will write the sign and after the number. It's also important to find what is a charge. Charge is the difference between the number of the protons and the number of the electrons on the shell. So here on the reaction you can find that lithium had 3 protons and 3 electrons, and initial charge will be 0 because of the same number of the negatively and positively charged subparticles. So after the reaction, lithium will donate 1 electron and act as a reducing agent. And we will observe formation of the ion. So charge after the reaction will be 1 plus because you will have only 2 electrons and 3 protons in the nucleus. Let's come back to the oxidation state. So oxidation state of the uncombined elements will be always equal to 0. The example is any gases, so hydrogen gas, chlorine gas, any metals such as the iron, aluminum, etc. Oxidation state of the ions in ionic compound will be always equal to the charge. It's also important to mention oxidation state of the oxygen, which is usually displays oxidation state -2. The exception will be peroxide, where oxygen will display -1 oxidation state, and the oxygen difluoride, where fluorine will be more electronegative than oxygen and force oxygen to become 2+. Oxidation state of the hydrogen will be usually +1. The exception will be metal hydrides. Metals will be always positive, that's why they will force hydrogen to become negative. So here we'll expect oxidation state -1. So from the unit of the periodicity you should remember that first group will be always +1, the second group +2, the third +3. Non-metal, different oxidation state, but you will expect -4, -3, -2, and -1 relatively. However, fourth group can be +4 and fifth +5. So let's just write that the metals will be always positive, they will be never negative, while non-metals, they can represent both positive and negative oxidation states. Using the periodic table, you can find that the oxidation state of the magnesium in the magnesium carbonate will be 2 plus and the oxygen 2 minus. But how you can find oxidation state of the carbon? In order just to explain, I will draw all the atoms separately. And here you will find that the carbon is X and the overall oxidation state will be equal to 0. If you have 2 plus and 3 2 minuses, you can just write the simple mass equation, not minus, plus 2 plus X plus 3 multiplied by minus 2 equal to 0. So X will be equal to plus 4. So here you'll find that the oxidation state of the carbon in the magnesium carbonate is plus 4. So let's train and solve couple questions on the calculating oxidation states. I will write the examples, you can put pause and try to solve by yourself. And after we'll solve together. Sodium chloride, let's draw it. Here you will have overall oxidation state 0. Oxidation state of the sodium 1 plus, because it's a metal of the group 1. And the oxidation state of the chlorine will be 1 minus, because it's a non-metal. And it's located in the group 7. So let's draw equation. So plus 1 plus minus 1 equal to 0. Potassium permanganate. Here we have 1 atom of the potassium, 1 atom of the manganese, and 4 atoms of the oxygen. Potassium has like positive oxidation state, oxygen usually minus 2, and the manganese unknown, because manganese can represent many oxidation states. So here you can form equation 1 plus X plus 4 multiplied by minus 2. And the oxidation state of manganese will be equal to plus 7, because overall oxidation state is 0. Sulfuric acid, we have 2 atoms of hydrogen, each one will be 1 plus, sulfur with the unknown oxidation state, and oxygen as usual minus 2. So let's write it. And the overall we have oxidation state 0, because sulfuric acid exists in the nature. So plus 2 plus X plus 4 multiplied by minus 2 equal to overall oxidation state 0, and here we can find that the oxidation state of the sulfur will be plus 6. And let's move to the ions. So here we have dichromate ion. So we have 2 atoms of the chromium. Chromium can represent many oxidation states, and oxygen, which usually represent negative 2 oxidation state. Overall oxidation state will be equal to not 0, it will be equal to minus 2, because this is an ion. So again we can form our equation 2x plus 7 multiplied by oxidation state of the oxygen equal to oxidation state of the ion. So x will be equal to plus 6. Okay, let's do one more to the ions. Here we have sulfate, sulfur with an unknown oxidation state, oxygen with a known minus 2, and overall it will not be 0 again, it will be minus 2. So here we can construct our equation. If sulfur is X, so X plus 4 multiplied by minus 2 oxidation state of oxygen will be equal to overall oxidation state minus 2. So sulfur will be plus 6. Guys, I hope it's kind of clear how to solve this type of the questions. So let's move to the reactivity series. Here you can find the reactivity series of metals. So on the left side, it's a highly reactive metals. So it's a metals of the group 1 and the group 2. In between, it's a moderate, and on the right side, it's a least reactive. So let's learn how to write the half equations. Here we'll provide an example with the zinc and the copper sulfate solution. From the reactivity series, you'll find that zinc more reactive than the copper. That's why it will replace copper from the solution. And oxidation state 0 become 2 plus, oxidation state of the copper 2 plus become 0. what will happen? What you will observe? You will observe that the thing will lose 2 electrons while the copper will gain 2 electrons. So on the left side, you here separately for the zinc will write zinc 0 will become zinc 2 plus. So zinc in the beginning will have 30 protons and the 30 electrons because overall charge is 0. After 30 protons but 28 electrons. So what will happen? Zinc will lose 2 electrons. So this is the oxidation process. And the copper 2 plus become copper 0. So copper has 29 protons and 27 electrons in the beginning because of the positive charge. After it will be 29 protons and 29 electrons. So here it will gain 2 electrons and this is a reduction process. So let's write these equations together and form half equations. So oxidation, it's a zinc 0 will move to the solution. So zinc will lose 2 electrons and become aqueous 2 plus zinc. On the redox side, copper from the solution will move to the solid state. So copper 2 plus 2 electrons will become solid copper 0. Electrons from the left and right side can be cancelled. Just copy left side zinc 0 plus copper 2 plus and copy right side zinc 2 plus plus copper 0. So here we have half equation for the oxidation and reduction processes and the full equation, our full ionic equation. Okay, so let's learn type of the redox reactions and write the half equation for each of them. Let's start from the combination reaction. It's the same as the addition reaction. A plus B will form C. So let's burn carbon in the atmosphere of the oxygen with the formation of the carbon dioxide. We will write the equation and all the states. And the first step, guys, is to define oxidation state. So oxidation state of the carbon is 0, become 4 plus. Oxygen will be 0 and after 2 minuses. So let's write the equation for the carbon. And the problem can arise when you cannot define is it reduction or oxidation. So how you can find? Let's write 4 pluses for carbon, 0 and 4 minuses. And after you will observe that they are minus 4 electrons because you will lose 4 electrons in order to become 4 plus. So this is the oxidation process, plus 4 electrons on the right side and oxidation process. And other process should be reduction process. So oxygen 0 will become negatively charged ion, yes? So again, you can check it. So let's write oxygen 0 will become oxygen 2 minus. For neutral atom, let's write 4 pluses and 4 minuses. For charged, they should be 2 extra minus. So you will get 2 extra electrons. If you will accept electrons, it will be reduction process. Yes, so you will write plus 2 electrons. But the mistake here that you have 2 atoms of the oxygens. You cannot separate molecule. So on the right side you will put 2 and multiply by 2. Yes, so here will be 4 electrons. Cancel electrons on the right and the left side of the half equations and just copy left side carbon 0 in the solid state plus oxygen 2 in the gaseous state and copy right side. So here you have carbon 4 plus and you have oxygen 2 minus. So that will be our full ionic equation for the reaction, guys. Okay, so let's do one more. So decomposition reactions. Let's decompose potassium chlorate. Okay, we will decompose potassium chlorate. Potassium chloride and oxygen will form on the side of the products. So first of all, define oxidation states, potassium 1 plus and oxygen 2 minus. Let's do calculations. 2 multiplied by 3 minus 6 plus 1. So x will be equal to plus 5. On the right side, it will be 1 minus. Oxygen 0. So let's write first of all equation for the chlorine. Plus 5 and the form ion chlorine minus 1. Yeah. So is it oxidation or reduction? Again, let's draw it. Plus 5 protons without pair. There are no pair for 5 protons. And the chlorine minus 1, it's 5 protons. So here should be 6 electrons. So 1 electron without pair. So in order to become chlorine minus, we need to get 6 electrons. So this is a reduction process. If this one reduction, so the next will be oxidation. Oxygen 2 minus will become oxygen molecule with oxidation state 0. So let's check it. Let's write oxygen 2 minus, okay, and oxygen 0. So here, guys, again, you'll write the ion. Let's just do 3 pluses. So in order to become 2 minus, you need to have 5 electrons, 3 pluses and 3 electrons. So 2 electrons will be donated, yes? So if you lose 2 electrons, this will be oxidation process. Let's write on the right side, plus 2 electrons. Okay, here we cannot cancel. That's why the number of donated and accepted electrons should be the same. We will multiply by 2 and by 3. Why? Because overall the number of the electron will be 12. So multiply by 2. 2 here, 12 here, 2 here. Okay, multiply by 3. So 3 oxygens here and 12 electrons was donated, and 12 electrons here should be accepted. You see, the number of the donated and accepted electrons should be the same. And after you will be able to cancel them. Okay, after you will cancel, you will write full ionic equation, copy left side, so chlorine plus 5 solid state plus 2 oxygen multiplied by 3, it will be 6 oxygen 2 minus. Okay, and the right side, it's 2 chlorine ions in the solid state plus 3 oxygen molecules with the oxidation state 0. This is our full ionic equation. Just copy left side to the left, right side to the right. That's all. Okay. So next type of the reaction, it's displacement reaction, and here I will give you opportunity to solve this equation by yourself. Okay, so let's use the simple example of the chromium oxide reaction and aluminium. So aluminium as a more reactive metal will displace chromium from the chromium oxide with the formation of the solid chromium. So do it by yourself. Okay, put pause and let me show you answer here. So after you will finish, you can check it. So the last example, it's a disproportionation reactions when the same atom on the product side will represent different oxidation state. Here we can use example of the peroxide, which after the decomposition will form water and oxygen. So if you try to identify oxidation state, it will be 1 minus on the reactant side. So here it's exception, you know, and 2 minus on the right side and 0 on the right side. You see, it will represent different oxidation state, but it's still the same atom. So let's write the half equation for the first oxidation state with the formation of 2 minus ion. So how to find, is it oxidation or reduction process? You will do the same. Let's draw ion. Here you have 3 electrons, 2 protons. On the product side, 2 protons and 4 electrons. So you need to get extra 1 electron. And what does it mean? It will be reduction process. So you will gain 1 electron. As the process, as usual, will be oxidation. Okay, oxygen 1 minus with the formation of the oxygen molecule with the zero oxidation state. Again, we will draw it. So negative 1. In order to be negative 1, you should have 3 electrons. And in order to be 0, you should have 2 electrons. So 1 electron will be donated. If electron will be donated, it will be oxidation process. So here you have 2 oxygen, that's why 1 will be multiplied by 2 and you'll write 2 electrons on the right side. Okay, we cannot cancel because you have different number of the electrons on the first and the second half equations. Multiply first one by 2 and the second by 1 in order to reach the same number of the electrons. So let's cancel them and write the full ionic equation. 2 oxygen 1 minus plus 2 oxygen 1 minus. We will form oxygen 2 minus in the water and oxygen molecule with oxidation state 0. So we can combine 2 oxygens with a negative 1 oxidation states. So it kind of obvious here. And this will be 2, 2, 2 minus plus, okay. So this will be our full ionic equation, okay. So thank you very much guys for your attention. See you.